Okay, so to solve this one, we're gonna have to square twice. So I'm gonna copy it for now, as is. And I'm gonna square both sides. So it's gonna get a little bit complex here. In fact, I'm gonna move the right side over because that part actually simplifies quite nicely. But what doesn't necessarily simplify in a quick and easy manner is this piece because that square tells us we have to multiply it by itself. That means you have to FOIL it out. Okay. So let's see if we can follow the FOIL. So the square root of z plus 4 times the square root of z plus 4 is z plus 4 because the square roots cancel. Okay. Then the outer is 1 times root z plus 4. So that's root z plus 4. The inner is also 1 times root z plus 4. So you have another root z plus 4. And then the last is 1 times 1, which is 1. So you basically just have to follow the distributive property and the FOIL acronym helps us keep track of that. And maybe the hardest thing, if anything, to understand is why is the square root of z plus 4 times the square root of z plus 4 z plus 4. So understanding that, that'll help you know why that z plus 4 ends up there. Knowing that though, if you were able to follow that, the other thing I can do is I can combine these middle terms and I have 2 root z plus 4s plus 1 is equal to 3z plus 1. Now, we're obviously not done. I'm gonna remove these steps, hopefully feeling confident that you were able to follow those. And of course, you can, watch the first part of the video if you need to. But let's see. I'm going to subtract z. So I'm gonna be left with a 2z here. And then I'm also gonna subtract a 4 over here and over here. So I'm left with a -3. And let's leave it like that for now. You may be able to handle working more steps all at once, but I think where we're at is fine. I'm gonna subtract the 1. I could have done that in the previous step, but that's okay. And then I'm going to divide by 2. Oh, and I shouldn't forget this -4 over here. So I'm left with square root of z plus 4 is equal to z minus 2. Now I'm going to square both sides. Remember I said earlier I was going to square twice. So that leaves me with z plus 4. Now I need to square this binomial, and I'm going to FOIL it out. I'm going to try to do it in my head and just try to be real careful not to make any mistakes. So it's going to be first, and then the outer is minus 2z. The inner is minus 2z, so it's going to be minus 4z. And the last is going to be -2 times -2, which is 4. And then I know I'm running out of space here, but I'm going to go ahead and subtract the z and subtract the 4. And that leaves me with a 0 is equal to z squared. I needed to subtract the z and subtract the 4 minus 5z, and these evidently cancel. Assuming I haven't made any major mistakes or minor ones, I'm going to factor out a z over here. And then set each piece equal to 0. There's nothing else to do here. So I have a potential candidate for a solution. And my other one is 5. The last thing to do is to check our work. And so I am gonna get rid of all of this because I'm assuming I followed all the steps correctly. But even when you follow the steps correctly, sometimes it's the case that one or none of them actually are valid solutions. So I've got the square root of z plus 4 plus 1 is equal to the square root of 3 times z plus 1. And we're going to copy this twice because we have to check the 0 and the 5. So we've got to check the 0 and we've got to check the 5. So this is square root of 4, which is 2, plus 1, which is 3. And then 3 times 0 is 0, plus 1 is 1. So this is a 1. So it appears that this one is not valid because this is false. This is the square root of 5 plus 4, which is the square root of 9, which is 3. On this side, it's the square root of 15 plus 4, 15 plus 1, which is 16. Square root of 16 is 4. So this other one does indeed work. So 0 is what we call an extraneous solution, but 5 is an actual solution.